Hi, I'm Camille Cole. My supervisor is Dr. Wei Zhang, and my coordinator is Dr. Albert. Today, I'm excited to present the preliminary process I've made on my research project called a deep learning-based test summarization for generating MARC standard description notes for a community information directory. To begin with, let's start with a short introduction. I'm focusing on leveraging NLP to automate the process of generating summary with a specific standard. The standard is widely used in library and information system. Back in the old days, the community service directory in SA was a physical print with simple categories. Nowadays, this directory is digitalized, also give us more information like services they offer when they are open or even comments from organizations. In the previous literature review, I came up with 4 important questions to explore. To answer them, let's go through. Out of the different type of model and technique for summarization, single document and abstractive summary will be used based on the input and output type. Also, domain specific will be used based on the purpose. And rather than RNN graph-based model, transformer model will be used. Move on to question 2. What are the problems and possible approaches in the test summarization? Firstly, we need a way to come up with a suitable original document. Hence, we will try different methods to select features. And speaking of the datasets, in the current dataset, some of the entity doesn't have ground truth yet, but we're working on the solution. We're also aiming to create a summary that matches a specific standard. One solution is to incorporate transfer learning and fine-tuning on domain-specific data. In short, we will use GRU score, BLEU score, analysis like NER overlap, position score, and or human evaluation to evaluate performance. Over data from data SA, called SA community, are our datasets. There are 5 main steps. First, we gather up the information, then we clean things up. Also, feature selection is very important before moving into summarization. And finally, evaluation, comparing our summary with reference summary and other things. The workflow revolves around the 5 tasks. All these tasks operate within the framework of 3 main components. The first component is pre-processing and method development. And then incorporate data with ground truth for fine-tuning. And the final step is leveraging unlabeled data to enhance the outcome and also apply to real world. Next, let's explore of the datasets. Allow me to introduce the SA community datasets, or call it CVCRM-DM for short. It is a repository of South Australia Community Service covering different sectors. Complementing this dataset is SubjectDB. This explorer categorizes over 14,000 organizations, cover different areas. The access to SA community dataset and subject dataset is available through SA community website and also SA government data portal. Here shows the key features from CVCRM dataset. Categorized by the purpose of them, there are 3 main groups. Organization name and ID serve as primary keys. Street address, city contact, answer who are they. Services tagline, commence eligibility and fee, answers what they offer. One thing to notice is that they are open field, which means user can input free text information such as comment, description, and other unstructured textual content. To visualize CVCRM, here is a data model representing the data fields. The second dataset is straightforward with all the predefined index categories. As we look at the word cloud, here we observe that the organization with focus on social and activities, churches and religious, children, service, and sport-related entities form the predominant clusters. Take Adelaide Hills Library and University of Adelaide as examples. They both have their set of predefined topics or subjects, and these are considered closed fields. This database formed the bedrock of the project. but cleaning and preprocessing the raw data are needed, and here are the workflow. After importing the dataset, mapping and combining are needed. A handling of drop organization with branches are necessary given their ground truth are mostly the same. Concatenating the field into two groups, open and closed field, and dive deep into these two sets, especially open fields, to remove outliers and tags preprocessing. And then it's up for feature selection before applying summarization. In order to get the clean subject dataset, it's necessary to map these two tables, and then combining the clean datasets with CVCRM datasets using the primary key ID and name. Cities falls under the category of the closed field. In the dataset, it got a total of around 1,300 cities. The raw city fields was not consistent, so it's needed to imply a fixed format for the city names, including removing any instances that end with .sa, along with eliminating extra spaces. After the data preprocessing, around 900 something cities are now accurately and uniformly cleaned. Move on to preliminary analysis. Here to discuss critical steps in preprocessing started with the removal of organization with multiple branches. Oftentimes, entities like RSL, Red Cross, they have the same ground truth. However, this duplication can significantly impact summarization models' effectiveness. First approach involved manually scanning entity with the term branch, yet this proven impractical, yielding only 240 cases. Second approach utilized fuzzy strength matching, which measured the entity similarities. However, setting an optimal threshold is the issue. Assuming the threshold is 70, in the table above, they are correctly labeled. On the table down here, some true branches with a very low similarity score, and also there are cases that they are identified as false positive. A reliable solution is to use NER to recognize geographical locations and then removing them from the entity names. In the experimentation with the Spatie Library's English language model, the small model identified close to 400 entities, while the large one catch 556. However, a significant portion of the entity remained unidentified. To address this issue, training a custom NER model specifically for city in SA is done. 2,000 annotated samples were used to train the model on top of the existing English language small model, and the output has been promising. Now, let's address another issue related to open fields. Community members and volunteers can both contribute to the open field. Looking at the portion of missing values, all the open fields contain a different level of missing data. To dive deeper, let's do a length and word counts on these fields. We can observe that some extreme numbers on the fields like services, comments, and so on. The field service plays important roles to the summary. And here are the steps to enhance the data quality to remove the irrelevant entries, and also test preprocessing has been done, and here are the steps. Now, let's discuss our upcoming plan, which revolves around two critical aspects: the encoder-decoder approach for summarization and the utilization of unlabeled data. I move ahead with using transfer learning with Hugging Face T5-based and BART-based model. The next step is to fine-tuning this model with this specific dataset with ground truth data. And that's the end of the analysis presentation. Thank you for watching.